Today in geometry, we are going to start looking at probability. This is Envision's chapter 12. So first let's talk about what is probability, get some of our definitions and vocab out of the way. So probability is the chances of an event happening. An outcome is a possible result of an experiment. An event is the set of outcomes of an experiment. The sample space is the set of all possible outcomes of an experiment. Mutually exclusive events have no outcomes in common. Non-mutually exclusive events have outcomes in common. The complement of an event is the set of all outcomes in a sample space that are not included in the event. Two events are independent if and only if the occurrence of one event does not affect the probability of a second event. If A and B are mutually exclusive events, then the probability of A or the probability of B equals the probability of A plus the probability of B. The probability of A and B would equal 0. If C is the event that A does not occur, then the probability of C equals 1 minus the probability of A. That's the complement. So this first one, this is our mutually exclusive. This is our complement. If A and B are not mutually exclusive, then the probability of A or B equals the probability of A plus the probability of B minus the probability of A and B. So that's not mutually exclusive here. If A and B are independent events, then the probability of A and B equals the probability of A times the probability of B. So if the probability of A and B equals the probability of A times the probability of B, then you know that they are independent events. All right, so let's look at an example. Example number 1, you roll a standard number cube one time. We're going to let E represent the event that we roll an even number. So in our diagram here, this is going to be our evens. So even numbers on our cube, 2, 4, and 6. T is going to represent the event that we roll a 3 or a 5. This whole thing is our S, our sample space. So what's left is our 1. So what's the probability that you roll an even or roll a 3 or a 5? So probability even or 3 or 5 are T. Or means we're going to add. So what's the probability that we're going to get an even? We have 3 even numbers out of a total of 6. Plus, now the probability that we would get a T, a 3 or a 5, we have 2 chances out of, again, 6. So when we add that, we get 5 out of 6. So the probability that we would get an even or a 3 or a 5 is 5 out of 6. Number 2, you roll a standard cube once. What's the probability that you roll an even number and a 3 or 5? So the probability that we get even and a T. This is going to be 0 out of 6, which is 0. Because if I only roll it one time, I'm only going to be able to get one answer. That one answer can never be even and a 3 or a 5. Number 3, you roll a standard cube once. What is the probability that you do not roll an even number? So this is going to be 1 minus the probability that we do get an even. The probability that I get an even was 3 out of 6, so 1 minus 3/6. So that's going to give me 3/6 left, which is 1/2. Number 4, we have a box that contains 100 balls. 30 of the balls are purple, so purple we have 30 out of 100, which is 0.3 or 30%. 10 are orange. So orange is 10 out of 100, which is 0.1 or 10%. If you select one of the balls at random, what is the probability that each of the following events? A, the ball is purple or orange. So probability P or O. Or means we're adding. So we have 0.3 plus 0.1, which gives us 0.4 or 40%. The ball is not purple or orange. So the probability of not P or not O. So the probability that it was P or O was 0.4. So the probability that it's not that is going to be 1 minus 0.4, which is going to be 0.6 or 60%. Number 5. A jar contains 12 green marbles and 8 violet marbles. A marble is chosen at random from the jar and then replaced. Another marble is chosen at random from the jar. Does the color of the first marble chosen affect the possible outcomes for the second marble chosen? Well, let's just make a little list. Okay, so my first time, I have 12 green and 8 violets. So my first draw, the probability of getting green is 12 out of 20, or 3/5. The probability of getting violet is 8 out of 20, or 2/5. Now we put the marble back, and we draw again. So the second time, since we put the marble back, I still have 12 green and 8 violet to choose from. So again, the probability of green is still 12 out of 20, or 3/5. The probability of violet is still 8 out of 20, or 2/5. So no, the first one drawn is replaced so it doesn't affect the outcome of the second one drawn. Therefore, they are independent. Number 6. A marble is chosen at random from the jar from number 5 and not replaced. Another marble is then chosen at random from the jar. Does the color of the first marble chosen affect the possible outcomes for the second marble chosen? Again, let's just investigate that. So the first time, start out with 12 green and 8 violets. My probability of getting a green is still 12 out of 20, or 3/5. Probability of getting a violet is 8 out of 20, or 2/5. So now my second time, I have different options. So let's say I got a green one the first time, and I don't put it back. So now then I only have 11 green to choose from, but 8 violets. Let's say the first time I chose a violet, and I didn't put it back. Or I have 12 greens and 7 violets. So this time, my probability of getting a green would be 11 out of 20. My probability of getting a violet would be 8 out of 20, or 2/5. Or the probability of getting a green would be a 12 out of 20, 3/5. Probability of getting a violet would be 7 out of 20. So we see that yes, since we don't replace, the first one drawn affects the second outcome. Therefore, these are not independent events. Number 7, there are 10 cards in a box. 5 are black, so we have 5 black, and 5 are red. 2 cards are selected from the box, one at a time. A card is chosen at random and then replaced. Another card is chosen. Does the color of the first card affect the possible outcomes of the second card? No, because the first one was replaced. So if we replace it, and we have the same probability the second time around. B, a card is chosen at random and not replaced. Then another card is chosen. Does the color of the first card chosen affect the possible outcomes of the second card chosen? Yes, because the first one was not replaced. So yes, that's going to affect the outcome of the second one. So our probabilities will not be the same the second time around. Let's go to our next page. Alex cannot decide which shirt to wear today, so he chooses one at random. The probability of rain today is 40% or 2/5. So the probability of rain is 0.4 or 2/5. What is the probability Alex chooses a yellow shirt and it does not rain today? So first let's see what's the probability of getting a yellow shirt. So over here we see we have 2 yellow shirts out of 4 yellow shirts. So the probability of getting a yellow shirt is 1/2. And it says does not rain, the probability that it rains, so the probability of no rain is going to equal 1 minus the probability that it rained, 0.4, which is going to give me 0.6. Or 1 minus 2/5, which gets me 3/5. So now we want the probability of yellow and no rain. Anytime I have an and in here, I'm going to multiply my probabilities. So probability of yellow, 1/2, times the probability of no rain, 3/5. Multiply those together and I get 3/10, or 0.3, or 30%. Number 9, what is the probability that Alex chooses a yellow shirt and it does not rain today? Or Alex chooses a green shirt and it rains today. So first we want probability yellow and no rain. Or the probability green and rain. So the probability yellow and no rain, that's what we just found. That was the 3/10. Or, so that means we're going to add. So right here, let's look at this. The probability of green. Probability of green, there's 1 green shirt, so it's 1/4. The probability of rain, we know it was 2/5. So the probability of green and rain, we multiply. If we do and, 1/4 times 2/5 equals 2/20 or 1/10. So that's the probability right here. So we need to add that here. So when we add them, we get 4/10 or 0.4 or 40%. Number 10, you spin the spinner 2 times. Assume that the probability of blue each spin is 1/3 and the probability of orange each spin is 2/3. What is the probability of getting the same color both times? So the probability of blue is 1/3. The probability of orange is 2/3. What's the probability of getting the same color both times? So first let's find what's the probability of getting blue, blue. So that's going to be 1/3 times 1/3 because it's blue and blue, so we multiply 1/9. What's the probability that we would get orange and orange? So we multiply 2/3 times 2/3, and we get 4/9. So now it's the probability that we get blue, blue, or the probability that we get orange, orange. So we add because we have or. 1/9 plus 4/9 gets us 5/9. Number 11, what is the probability of drawing an ace from a deck of cards? Okay, there are 52 cards in a deck. You have 4 suits in a deck. Each suit has an ace, so we have 4 aces. So the probability of getting an ace is 4 out of 52, which will reduce down to 1 out of 13. All right, so now what's the probability of drawing a king? So the probability of getting a king, again, 4 out of 52, or 1/13. Replace the card, so we put it back, then draw a 6. Well, what's the probability of getting a 6? Again, 4 out of 52, or 1/13. So we want the probability of getting a king and a 6. So I multiply because it's an and. 1/13 times 1/13 gets me 1 over 169, which is 0.0059, or about 0.59%. What is the probability of drawing a queen? So the probability of a queen, again, 4 out of 52, or 1/13. Not replacing the card, so now I only have 51 cards to choose from. Then drawing a 2, so the probability of a 2. So now I still those 4 2s, but now I only have 51 cards to choose from. So the probability of a queen and a 2 gets me 1/13 times 4/51st, because I'm and, so I multiply, and I get 4 out of 663, which is 0.006, or 0.6%. Right, so that's day 1 of probability. Our homework today is on Envision. Next time we will look at some more probability.